Welcome back. This is part 2 on the review of right angle triangle trigonometry. And so today we're going to go through how to find an angle as well as how to find a side of a right angle triangle. So first off, our example, find the angle of the following triangle. This is our triangle here. First off, right, I'm going to label it. The opposite of the angle is the opposite side. The opposite of the right angle, I'm going to denote it as the hypotenuse. And my lucky last side is going to be called the adjacent. Now, that's my first step. I've labeled the triangle. My second step is, if it's hard for you to, again, remember the formulas, I'm going to write down SOHCAHTOA. That's a strategy. Okay. I've done that. Now, how do I know which one to use? Whether I need to use sine theta, cos theta, or tan theta? In this case here, I've got a length to every single side of this triangle. So I can use whatever I would like, okay? If I take away the length of the adjacent side and I've only got the lengths for the opposite and the hypotenuse, then of course I will only use sine, right? O and H, that's the only thing I've got available, okay? Just please make sure that you know when to use, when to use sine, when to use cos, and when to use tan, okay? Now, in this case, to make it easier, I'm just going to use sine theta, because why not? Using our acronym, SO means sine theta equals to O over H. I've done that. I'm going to do sine theta equals to, substituting what O is, which is 3 over 5, right? H equals to 5. Done that. Now, the question says to find the angle. Well, how do I make theta here by itself? Well, the opposite of sine is sine dash 1. I'm going to open the bracket and I'm going to put in 3/5. I'm going to close it. Now I'm going to write here as a little note, the opposite of a sine is sine dash 1. For cos, the exact same, it'll be cos dash 1. And lucky last, tan will be the exact same, but it'll be tan dash 1. You can find that into your calculator, okay? Anytime that you're trying to find an angle, this is what you're going to be using. Put that into your calculator, right? Just like this. Follow the steps in the red. I call this button right here, to be more specific, this one here, the bubbles button. That's just how I remember stuff, or how to remember that button. Okay, just looks like bubbles. Now I'm going to use that, and what I should get is theta should equal to 36 degrees, should be 52 minutes, 11.63 seconds. Okay, that is my answer. And now I'm going to go through my third example. Now, my third example is find the side lengths of the following triangles. Okay, this triangle here, again, first step is to label it. So I've got my degree. I'm going to label this side the opposite. Got my right angle. I'm going to label this the hypotenuse. My lucky last is adjacent. So, done that. I'm going to write SOHCAHTOA right here, just so that I remember the formula and I don't get stuck. Okay, I've got no length on the opposite side, but I've got one on the adjacent and the hypotenuse. Which one should I use? Well, I think I need to use cos theta, because I got A and I've got H. Right, I've done that. I've identified it. And I'm going to write down the formula. Cos theta equals to A over H. All right, done that. I'm going to sub it in. Cos theta equals to 54. That's my degree. Equal to A, which is 12 centimeters, and H equal to X. Okay, I've done that. Now, how do I make x not on the denominator? Well, let's just multiply x by itself. Cancel this one out. And what I will get is x times cos 54 degrees equal to 12. Okay, how do I get x by itself? Well, I need to divide cos 54 on both sides. This will cancel out. And what I get is I will get x equals to 12 cos 54 degrees. Put that into your calculator. Okay, and you should get 20.4156. If I want to put that into 2 decimal places, I get 20.42 units in this case. So that's my first answer to my first question for finding the side length. This is my second question. Again, I'm going to do the exact same. My first step is to label. This will be my opposite. This will be my hypotenuse. This will be my adjacent. Once I've done that, what I'm going to do is write down SOHCAHTOA. Okay, so what I've got here is I've got the length of O and the length of H, but no A. So looking at SOHCAHTOA, my acronym, this is what I'm going to be using. All right, sine theta equals to O over H. Always write the formula for you to remember. Equals to, all right, let's sub it in. Theta equals to 48 degrees. O equals to X. H equals to 20. How do I get X by itself? I need to multiply the 20 on both sides. This will cancel out. And what I will get is 20 times sine 48 equals to X. Put that into the calculator, following the red. Okay, that's how you're going to put it into the calculator. And what you would get is X equals to 14.8628. Put that into 2 decimal places and you should get 14.86 units. So that's your answer. And that'll be all. All right, I'll see you in the next one. Bye.